In this video, we will learn about the quicksort algorithm and how to implement it using C++ code. Quicksort uses the concept of a partition when sorting the elements. Let's take a look at how a quicksort would work on the collection of elements we've been using in these examples. A vector storing the values 20, 10, 50, 2, and 5. The first step is to pick an element to use as the pivot. It doesn't matter which you choose. For this example, let's start with a pivot of the last element, which is 5 in this case. Each element less than 5 will go to the left of it, and each element greater than 5 will go to the right of it. Since 20 is greater than 5, we put it to the right of it. Since 10 is greater than 5, we add it to the right of it. Since 50 is greater than 5, we move it to the right of it. Since 2 is less than 5, it remains to the left of it. Next, we will choose another pivot, for example 20. On this pass, the 10 will be moved to the left of 20. The elements in the collection are now in order. Now that we understand the concept of a quicksort, let's learn how to implement it using C++ code. Next, we will create a function with an integer return type named partition, which will take in 3 parameters, a vector of integers named list, an int named low, and an int named high. One important callout is to put the ampersand in front of the name list to make sure that the changes we make to the list are reflected. This function will be responsible for choosing a pivot and sorting the elements to the left and right of that pivot. Inside of this function, we will create an int variable named pivot that we set equal to list at index high. After that, we will have an int variable I that we set equal to low minus 1. After that, we will have a for loop that starts at int j equals low, runs while j is less than or equal to high minus 1, and increments j by 1 each time. Inside of this for loop, we will have an if statement that checks if list at index j is less than pivot. If so, we will increment I. Then we will move the element at index j before the pivot. We will have an int variable named temp that we set equal to list at index I. Then we will set list at index I equal to list at index j. After that, we will set list at index j equal to temp. At the bottom of the function, outside of the while loop, we will create an int variable named temp that we set equal to list at index I plus 1. Then we will set list at index I plus 1 equal to list at index high. After that, we will set list at index high equal to temp. Finally, we will return I plus 1. This wraps up our partition function, but we still need to write the function that will actually perform the quicksort. Let's create a function with a void return type named quicksort that takes in 3 parameters, a vector of integers named list, an integer named low, and an integer named high. Again, don't forget to put an ampersand in front of the name list. Inside of this function, we will check if low is less than high. If so, we will create an int variable named index that we set equal to a call to the partition function, with list passed in as the first argument, low passed in as the second argument, and high passed in as the third argument. Next, we will make a recursive call to the quicksort function and pass in list as the first argument, low as the second argument, and index minus 1 as the third argument. Then we will make another recursive call to the quicksort function and pass in list as the first argument, index plus 1 as the second argument, and high as the third argument. This wraps up our quicksort function. Inside of C++'s main function, we will make a call to the quicksort function and pass in numbers as the first argument, 0 as the second argument, and 4 as the third argument. The 0 is the start index and the 4 is the stop index, since our vector of numbers contains 5 elements. When we run the code, notice that the elements in the list were properly sorted, thanks to the quicksort code that we wrote. In this video, we will learn about the merge sort algorithm and how to implement it in C++. A merge sort breaks a collection down into equal halves over and over until each is an individual element, and then reassembles the collection piece by piece, sorting as it puts the elements back together. For example, let's start with the collection of elements 20, 10, 50, 2, and 5. First, we can break the list into 2 sublists. Since it is even, one sublist will have 2 elements, and the other will contain 3 elements. Now we have one sublist with the values 20 and 10, and the other with the values 50, 2, and 5. We can break the list on the left down into two sublists, one holding a value of 50 and the other holding a values 2 and 5. At this point, we can start recombining the sublists and sorting as we go. We will recombine the sublist of the 20 and the 10, putting the 10 before 20. On the right, we will recombine and sort the sublist, making it 2, 5, and 50. When we combine the two sublists, it gets sorted, and the result is the full list, becoming 2, 5, 10, 20, and 50. Now that we understand the concept of the merge sort algorithm, let's get some practice implementing it using C++ code. Let's create a function with a void return type named merge that takes in 4 parameters: a vector of integers named list, an integer named left, an integer named mid, and an integer named right. Don't forget to put the ampersand in front of the name list. Inside of this function, we will create an int variable named sublist1 that we set equal to mid minus left plus 1. Then we will create an int variable named sublist2 that we set to right minus mid. After that, we will have a vector of ints named left list and a vector of ints named right list. Then we will have a for loop starting at int I equals 0, running while I is less than sublist1, and incrementing I by 1 each time. Inside of this for loop, we will add list at index left plus I to our left list using the pushback function. Then we will have another for loop that starts at int j equals 0, runs while j is less than sublist2, and increments j by 1 each time. Inside of this for loop, we will add list at index mid plus 1 plus j to our right list. Next, we will create 3 int variables, one named index of sublist1, initialized to a value of 0, another named index of sublist2, initialized to a value of 0, and a third named index of merged list, initialized to a value of left. Next, we will have a while loop that runs while index of sublist1 is less than sublist1, and index of sublist2 is less than sublist2. Inside of this while loop, we will check if left list at index of sublist1 is less than or equal to right list at index of sublist2. If so, we'll set list at index of merged list equal to left list at index of sublist1. Then we will increment index of sublist1. Else, we will set list at index of merged list equal to right list at index of sublist2. Then we will increment index of sublist2. Outside of the if-else statement, but still inside of the while loop, we will increment index of merged list using the ++ operator. While index of sublist1 is less than sublist1, we'll set list at index of merged list equal to left list at index of sublist1. Then we will increment index of sublist1 and index of merged list respectively. In a similar fashion, we will have a while loop that runs while index of sublist2 is less than 2. Inside of this while loop, we will set list at index of merged list equal to right list at index of sublist2. Then we will increment index of sublist2 and index of merged list respectively. That wraps up the merge function. We still need to write the function that will actually be responsible for performing the merge sort. Let's create a function with a void return type named merge sort that takes in 3 parameters, a vector of ints named list, an int named begin, and an int named end. Don't forget to include the ampersand in front of the name list. Inside of this function, we will check if begin is greater than or equal to end, and if so, we will return from the function. Then we will create an int variable named mid that we set equal to begin plus end minus begin divided by 2. We will have parentheses around the expression end minus begin so that it evaluates first. Then we will make a recursive call to the merge sort function and pass in list as the first argument, begin as the second argument, and mid as the third argument. After that, we will have another recursive call to the merge sort function and pass in list as the first argument, mid plus 1 as the second argument, and end as the third argument. Then we will make a call to the merge sort function and pass in list as the first argument, begin as the second argument, mid as the third argument, and end as the fourth argument. Inside of C++'s main function, let's make a call to merge sort and pass in numbers as the first argument, 0 as the second argument, and 4 as the third argument. When we run the code, notice that the elements in our vector were successfully sorted, thanks to the merge sort algorithm that we implemented. Nice work.